Hey folks, welcome out there. I'm Ernie Roberts. I'm your host for TNLearn Summer School Mathline. We're just having a great time. Summer school, it's getting closer and closer to that fall start, you know. Some of you are going like my students out there are going like, ooh, August is coming really soon. But you know, August the 8th, we will be back live. But until then, we're giving you some great things to get you ready for school, a little bit of geometry introductions this week, and you know what? You could get to sit back, relax, take your pencils, your paper, and let's do some math, all right? And again, welcome to TNLearn Summer School. And let's see what we got going on today. What are our storyline today? What we got going? Teamwork counts. You know, this is so much of what goes on in mathematics. Things work together, whether it's students working together to solve a problem or information that comes together. And today we're going to look at creatures called angles that work together a little bit, all right? Some situations where we have to take an angle here and an angle there and see what we can do and pull it together, all right? So let's see what's going on. See what our first problem is all about. First of all, I've been using the word angle, and most of you probably already know what an angle looks like. This could be one, it could be short, smaller, it could be larger, it could all sorts of different type sizes here. This one would be what we would call an obtuse angle. But notice it says write 3 different names for the angle pictured below. Now, many times, I know my students are bad about this, and I know a lot of adults out there aren't really sure, well, what do? You know, you got 3 letters here. How do we name this thing? Well, first of all, let's just go to a few terminologies here, all right? This first one I want to pick up with you is the word vertex. And vertex, in this case, is E. It is a point, all right? It is the point E right there. And what it does, it basically is going to be our center of attention for the angle. These 2 sides are what we call rays. And they are the sides that would be ray EF. Notice I started with E. It's not FE. It starts at E, goes to F, and keeps going. And also we have the other little ray that's a side. That would be ED. And notice I've got these arrows going in only one direction. They're not lines. They are rays. See, there's a ray. There's a ray. So when we form an angle, basically we're taking 2 rays, and the vertex is that point in common. The vertex is that point in common, and there they become a nice looking angle. Now, they could make a straight line. Somebody say, well, could they make a straight line? Certainly they could. Certainly they could. And that would be what we call a straight angle, all right? The other situations, we've got options. It could be acute. It could be right. It could be obtuse, like this one is. There's a lot of variation in there. Now, if it's a right angle, there's only one way that can happen. If it's a straight angle, only one way that can happen. But for acute and obtuse, my, there are so many options. Now, you say, Ernie, are you going to get to the question? Yes, I will. Yes, I will. 3 different names for the angle pictured below, but I want you to understand why these are important, because that's how we're going to name our angle, all right? First of all, angle E is quite legit, all right? Angle E with your vertex. Now, I can't call that angle D. I can't call that angle F. I can only use a single letter with the vertex, all right? So there's one option right there. Notice the symbol for angle. It's pretty easy to look at, all right? The other options I've got, how about it? Let's go with angle D, E, F. In other words, I'm tracing it, D, E, F. And I understand those arrays that are coming to make that happen, all right? So D, E, F, notice E is in the middle. I can't go EDF or FDE. I've got to have E in the middle. And I know some of you are out there asking, well, Ernie, I'm listening. Could we rearrange the letters like FED? Yes, we could. FED. It doesn't have to be alphabetical. If it were having to be alphabetical, it would drive us all crazy, all right? Because there would be, pictures get more and more complicated, and it'd be very hard to make sure they do such. Also, you could put, a little number in there. We could call this angle 1. I don't know, it's asked for 3 ways, but I just added 1 to the picture there. But we could also name it with numbers, all right? So different approaches, different situations, and as I tell my geometry students many, many times, when we get going to big, complex looking problems, you're glad to have those numbers because they're much easier to locate rather than looking for 3 letters all the time. But anyway, these are all legit, legal, good ways of naming our big old angle right there. Angle E, angle DEF, angle FED, or angle 1, all right? So that's the first thing I want to make sure we understand, just the basics of angles, because I find out sometimes students are jumping in all these other terms and all these other words, but they don't know the basics, all right? So we've got to start with the basics, and then we're going to, speaking of basics, let's take a look at our types of angles. I've already mentioned them, but just a few little quick descriptions and definitions. Notice if it's acute, it measures somewhere between 0 and 90. Notice it doesn't quite get to 0. Now you say, well, Ernie, does that mean it's 1 degree or more? No, that means it could be a half a degree. It could be a quarter of a degree. It could be 1/100th of a degree. You get the idea. You get smaller, smaller, smaller. It just can't get quite to 0. Remember, this less than symbol here simply says just that m is going to, in this case, m is going to be greater than 0. On this end, it's going to be less than. This is measure angle A, by the way. This little combination here, some of you are probably, what does that mean? That means the measure, all right? And we put a little m in front of them when we're talking about measurement to talk about degrees. So this is between 90 degrees up here at the top, and back here we're at 0 degrees, all right? So we are dealing with degrees. That's our measurement here. Now when you get into pre-calculus out there, folks, you're going to learn how to measure these angles in what we call radians, having to do with pi. But today, we're all about the degrees. We're just going to be about simply degrees, okay? So just hang with me. Here we go. In the right angle, notice we've got that measure symbol going here. That tells me 90 degrees. By the way, let me go back here just a second, capture this one more time. Notice where the measure angle A is between 0 and 90. That's another way of looking at it. Basically, it's bigger than 0 and less than 90. So it falls somewhere in between there, some degree measure. It can get real close to 90. It doesn't stop at 89. Sometimes I have students and adults also that think, well, if it's 89 degrees, then that's where it is before you get to 90. Well, it is in terms of integers. But remember, we can have 89.5 degrees. We could have 89 3/4. You get the idea, 89.9999, you know, until you finally get to 90. But we avoid that. We avoid getting to 90 at all costs. Because once we get to 90, we have a right angle, not acute anymore. Now, let's see. There we go. Again, that's that measure angle A. That's what that M is standing for there, all right? Now, let's take a look at obtuse. Obtuse. It's a little bit bigger than 90. How big? Well, anywhere between 90 and 180. So once again, there's our measure angle A. By the way, those of you who've had Algebra 1, you know what this is. It's called a combined inequality. It means our value is somewhere in between 90 and 180. It basically reads that angle A's measure is bigger than 90, but less than 180 at the same time. So it's somewhere, has to be somewhere in between 90 and 180. So again, it's between 90 and 180. Got it. And then we come to the straight angle. Again, measure A. At this point, it's just simply 180 and degrees. Again, these are our degrees. Remember. Again, we talked about a little bit about radians. They come in pre-calculus when you get into the trig and all that good stuff based on pi. But I'll just let you get curious on it. Those of you who are wondering what I'm talking about there. All right, let's go to our next thing. What we got going here? We're going to look at some situations where we get these angles working a little bit here. And a right angle has a measure of 3x plus 6 degrees. So this time we are not telling you exactly what the degree measure is. Well, but you know it, right? A right angle is 90 degrees. So what we want to do is figure out what is x to make that happen. All right? So remember, we just said it. A right angle has 90 degrees. So what we're going to do, we're going to say this angle, this 3x plus 6, equals to 90. Now keep in mind, this is all basically about degrees. I'm going to look for a value of x that's going to make 90 happen here. All right? That's what we're looking for. That's what we're looking for. So let's see how this is going to go. We're going to first do a nice subtracting of 6. Oh, guess what? It's like pre-algebra, isn't it? This is so easy. It's going to be so easy. If you guys know your algebra, this is going to work beautifully. All right, so here we go. The 6's cancel. I'm left with 84 over here. And I've got 3x left to the left-hand side. Ooh, left on the left-hand side. That's pretty good. Again, this was subtraction property of equality. It means whatever we do to the left, we got to do the right. And folks, again, don't add 6 and 90. It ain't going to work, all right? You've got to subtract them. When you move it to the other side, you do the opposite of what it says to do, all right? Because you're basically undoing this expression on the left, all right, that makes our equation rock. Let's see where it's going to go. We're going to divide 3 into 84. I hope it goes evenly. I know it does because 8 plus 4 adds up to 12. Actually, our x value here is 28. It's going to be 28. A quick check. Always like to do that. Go back to 3 times 28. That is 84. Add 6. Bang, we are at 90. We are at 90. So again, once you work through these little problems, it's always good to go back and check because, hey, careless mistakes do happen. And I've been known to make a few of those, but we try to correct them though, okay? And that's why checking, you do it. When you have checks, it makes it a lot nicer that you can fix it before the teacher says, you got points off, all right? Now, let's go to our next problem here. We got a straight angle, has a measure of 15x minus 30 degrees. We're going to find the value of x here. Now, once again, straight angle has only one option, 180 degrees, 180 degrees. So here we go. Let's put it in here. We've got 15x minus that 30, and that is going to equal, folks, to 180. Everybody with me? You got it out there? There's your equation. Now, careful again. I'm always telling you be careful. You know that. But because I want you to be careful. When we move this 30 over, folks, it's a subtracting of 30, so we're going to add 30 to remove this. We're going to add 30. And if we add 30 to the left, we've got to add 30 to the right. And here we go. Say goodbye to the 30s. We got 15x equaling, woo, y'all can add that high. I can. 210. Y'all, can you watch a Mathline? Now, I'm going to do one thing. I'm going to go to the calculator to divide 15 into 210. So let's see what happens here. 210, we'll divide that by 15. It better come out. I'm hoping it comes out even. It's supposed to come out even. Let's find out. Woo, 14. It did. It came out even. So coming back to that, we now have our value x equals 14. So there's our final conclusion. Let's do a quick check over here. All right, 15 times 14 minus 30. The question is, does it equal to 180? Well, 15 times 14 is going to give us 210. We already realized that. If we subtract 30, guess what? We are good. We are good. It checks out again. Good stuff, all right? So, again, straight angle, right angle, only one option, all right? Right angle, you have to be 90 degrees. Straight angle, 180. Now, let's see what happens, perhaps, if we have acute angle going on here. Acute, let's get a little wow here. Ernie, you didn't say what the measure of that acute angle is. Well, I do know something about it. It can be what, between 0 and 90. It's got to be bigger than 0 and less than 90. It's a big and going there, all right? We call that a combined inequality. Ooh, combined inequality. Does that mean I want to write something like that? That does. Let's go back to algebra for a minute here, all right? So remember our boundaries for the acute angle is somewhere between 0 and 90. You say, well, Ernie, what's the angle in between? Is it x? No, we're not saying x is going to have values from 0 to 90. We're saying this expression, 3x minus 30, that's what we're going to solve for. We want it to be somewhere, the result to be somewhere between 0 and 90 based on this little value right there. So you go like, whoa, that means I've got to worry about two ends. Now, you know, I'm going to reference something here. I know a lot of teachers say that acute angles are less than 90 degrees. That's what you hear in your elementary school years. That's fine. It's true. It is less than 90 degrees. But there's also the lower boundary. We can't hit 0 and we can't hit a negative value. All right. So that's why I'm impressing upon you. This is not less than or equal to. All right. It's less than 90 and you got it, greater than 0. So keep that in your mind as we work through this. Now you say, ooh, refresh our memory. How do we solve combined inequalities? Well, we want to get x by itself in the middle. And right now we've got a 3 and a 30 that's hampering our workload on this, okay? So let's do this. Let's add 30. And guess what? We're going to add 30 over here. But my friends, everybody listen on me. Do not, I repeat, do not forget to add 30 over here. Okay, it's important also. All three places must be hit, so to speak. Oh, call it the addition property of inequality. Everybody's been hearing that equality out of my mouth so long. When inequality happens, they are the same properties here. With one exception, we have to divide by a negative, but we aren't dividing by a negative here. We're adding positive 30 to both sides. Gives me a 30 to the left. Now, these have gone away in the middle, so we are looking much nicer in the middle. We're down to 3x. And on the right, oh, be sure, we add 90 and 30, we get 120. Now these little guys are less thans. These are not angles. Sometimes less thans and angles start looking alike, all right? But this is all less than, okay? And we're saying basically this 3x is somewhere between 30 and 120. So we're saying basically this is greater than 30, less than 120, all right? As an and connecting those together. Let's divide everything out because we want x by its lonesome in the middle. Let's divide it right here. Divide by 3, divide by 3. And we're going to get a 10. We're going to have an x because goodbye 3s. And we're going to divide 3 into 120. I see 40. So this is our boundary. This is our boundary. Now let's go back and look at this just a second. If you put 40 right back here, see where my finger is pointing? My finger is pointing so well there. 3 times 40 gives you 120. If you subtract 30, you are at 90, all right? Which means you've got to be, again, you've got to keep this thing under control. It's got to be smaller than 40, all right? And up here on this end, if we put a 10 in here, we're down to 0, and we've got to be bigger than 0, okay? So that's our story, and that's what we're going to stick to it. The range of values, notice I use that expression, range of values, between 10 and 40, and you can't hit 10, you can't hit 40, but you can get really, really, real close, okay? As close as you possibly can. And there's your story on the acute angle there. So you say, well, Ernie, what are we going to do with the obtuse? It sounds like obtuse had a lot of values too. Yeah, there were a lot of ways to have obtuse angles. So let's take a look at this one. Let's see what we've got here. An obtuse angle has the measure of 4x plus 20 degrees. Here we want to find again, what are the range for the values of x? And again, obtuse, we already know the range goes between 90, 180 up there on the end, upper end. Let's see what's going to happen. We're going to put our less thans here, our less thans here. Notice what this does, this allows for the combined inequality to happen. We're basically saying that this quantity is going to be greater than 90 and less than 180. So let's see what we're going to do. We're going to put a 4x, and we're going to add 20. And again, the story is, let's get x by itself in the middle, okay? X in the middle. Could be a great TV show. Another spinoff for Mathline. Hey, mark that down, guys. We got a new show coming up there. All right, let's see what's going to happen when we get this subtracting 20 on all 3 occasions. And let's subtract 20 here. And while we're at it, let's subtract 20 down here. Does that clear us up? And here we are. As we subtract 20 from, we have 90 minus 20. It's going to give us a nice old 70 down here. Up here, we have still 4x hanging on. All right, everybody hanging with me. And up here on the upper end, we got 180 minus 20, which is going to give us, wow, what is it going to give us? It's going to give us 160, I believe. Now, we're ready to divide everything through by 4. Let's do that. Let's divide through by 4. We're going to divide 4 into 70. We're going to divide 4 into 160. And of course, we're going to take it right through the middle and say goodbye to the middle. We got x by itself. Now, I can do 160 divided by 4 pretty easily. That's going to be 40. So that's my upper bound. I can't quite get to 40, but I'm going to get close. I got x. Some of you are wondering, well, wasn't there a 40 on the last problem? Is it always going to be 40? No, it just happened to work out that way, okay? So just be cool. Just don't worry about it, all right? On the lower end, however, we've got this 70 divided by 4. Hold on just a second. Let's do a quick check on the calculator since some of y'all trust me. I hope all of you trust me, but we're going to look at it because I believe we're going to get an even number, but it is going to have a decimal involved. Let's see, 17 and a half, okay? 17 and a half. So we can go almost to 17 and a half on the low end, and above we can get close to 40. Very, very close, all right? Now, keeping in mind, a quick check, if you take 14 times the 17 and a half, you get 70. 70 plus 20 gives us 90. Remember, we don't want to equal 90. We want to be close, just close, not on it, okay? Over here, we want to get close to 180. We know if we put a 40 in there, we are going to pick up 180, which is too high. So that's, again, why we do not put the equals to under here. Do not put equals to. This is your range. It is somewhere between 17 and a half and 40. Very, very close. And when I say very, very close, I'm not talking about 39. I'm talking about 39, perhaps 0.9999999 until you get to the point where you get infinity, and you don't want to do that, all right? So take my word for it, gets real close. Real close. All right. There's your storyline. There's your storyline. Now, I said something about these angles work in pairs. Let's take a look at this situation. Sometimes we don't always, sometimes we have put degrees on here. See those little degrees? 69, there's 78. And notice here we've got two little angles and we get a big angle. So actually there are three, count them, three angles in this picture. I'm wanting to figure out how many degrees, that's what M stands for, what's the measure, of QPN. Now first thing I've got to do is find my Q, go to P, and then come up to N. That means I'm looking for, I'm going to put it in blue there, I'm looking for that whole big angle. And you know what I'm going to do? I'm going to use a thing called angle addition. I'm going to tell you that the measure of the 78 degrees plus 69 degrees, let's see if I can get those, is going to equal, well, what do you think? What do you think on that? Can we do that in our heads? It looks pretty large, doesn't it? It's going to be 140 something. How about 147? You want to check me on the calculator on that? Of course you do. Y'all were just waiting to see, did he do it right? Sure, let's check it out. We go to plus 69. I'm betting on 147 because it is 147. Now again, we added the 78 degree angle plus the 69 degree angle, and that's what we got was 147 degrees, all right? So there we have it. We call it the angle addition postulate. And by the way, some of you say, well, Ernie, how would we have named those small angles? How about NPR and QPR? Again, notice I put P in the middle each time. Here, P is in the middle because that's your vertex. So don't forget, that's how they work. By the way, they call these two small angles are adjacent. They share this common ray, and I like to say they lie next to each other. They lie side by side, and they form the nice big angle for you. Okay, so a little bit of going along with it there. So it's not always going to equal to 90s or 180s or zeros or things like that. Now, let's take a look at this one. Ooh, this one says, again, find the indicated measure. It looks a little bit different. There's a box here. What does that box stand for? That box says, let's make a right angle. That's what that box is there for. If it's not there, my friends, to begin with, you don't assume it, okay? You have to show that, or someone has to tell you that is a right angle. Now, X is our vertex, and according to this, I've got 26. Now, I know that if I look for WXY, it's a right angle. I know that's 90. I'm curious about what is WXZ. What is this little guy right there? Now, according to this, it looks like we're going to have 26 degrees plus something will equal 90, because that's what the big degree is, all right? So guess what? This is all about subtracting. Our little blank here, I'm going to put a blank here, is equal to 90 minus 26 degrees. Again, these work in pairs. They are adjacent. 26 plus something gives me the right angle. That's what we're looking at, all right? No degrees get lost. This is sharing that common ray. And again, they lie side by side, the little bi in blue and this little 26 degree angle here. And y'all got the idea? What's 90 minus 26 up there? Dooba-dooba-doo. I think it's 64. And that's what we'll have, 64 degrees. And again, these two guys would add up to give us 90. So answer, how about it? 64 degrees. So this comes off of what we call angle addition. When angles are adjacent, you can add the two small to get the angle that encompasses them together. It's called angle addition postulate in many cases, and it's a great little tool, Let's see if we can do a quick algebra problem with the angle addition postulate right here. Here we go. Got the figure ready for us here. And we're going to tell you that the angle GHE is equal to 66. So what we're saying here, we're going to say these two little angles, you see them right there, right here, they're going to add up to give me 66. So let's see what happens. How about it? 9x plus 3 plus 13x minus 25 equals to 66. All right, there's a start. Now let's piece these things together. I'm counting 22x, and you know what? That's because those are like terms. How about 3 minus 25 gives us minus 22, equaling to 66. Let's kick it in gear here. We add 22, you know that game, to both sides. I got 22x left to equal 88. I'm glad these came out even. All right, let's see what x is going to equal. X should equal 4. All right, so we're solving for x. We've got this situation. Let's see if we can find the other angles while we're at it. We've got 4, that's 36 plus 3, which will give us 39. Over here, we have, goodness, we have another 4 going in. That's 52 minus 25. It should give us 27. Question, 39 plus 27, 66. Bang, there you go. And that's how they work as a team. Teamwork for adjacent angles. There are other pairs of angles we're going to be discussing this on down the road to do the same thing. Thanks for tuning in today, and we'll see you again tomorrow.